Deployment of AI-driven robotics in manufacturing, 2024 rollout phases and $3 billion investment allocation for U.S. and China collaboration. Overview. The deployment of AI-driven robotics in manufacturing is on the cusp of a significant transformation in 2024, underpinned by a collaborative investment totaling $3 billion from both the United States and China. This initiative is designed to enhance the manufacturing sectors of both countries through the integration of advanced AI technologies and robotics, responding to the increasing global demand for automation and efficiency in production processes. Investment and rollout phases. The $3 billion investment will be executed in multiple phases targeting various aspects of AI and robotics applications in manufacturing. The urgency for enhanced automation and efficiency is driven by the escalating competitiveness of the global market. Experts predict that the AI sector will grow from $184.15 billion in 2024 to approximately $2.53 trillion by 2033, reflecting an annual growth rate of 33.83%. This investment aims to ensure that both nations capitalize on this burgeoning trend. Use cases and applications. AI-driven robotics will be utilized in several manufacturing applications, including 1. Supply chain optimization. AI systems will analyze data in real time to enhance supply chain efficiencies, leading to reduced costs and improved delivery times. 2. Predictive maintenance. By leveraging AI algorithms, manufacturers can predict equipment failures before they occur, minimizing downtime and maintenance expenses. 3. Quality control. Advanced AI technologies will ensure that quality assurance practices are more efficient, reducing defects and enhancing product reliability. For flexible manufacturing, AI-driven robotics will allow for more adaptive production lines that can quickly switch between different products, accommodating market demands more fluidly. Integration and collaborative efforts. The collaboration between the U.S. and China will emphasize joint research and development efforts, pooling expertise from leading companies and academic institutions in both nations. A major focus will be on establishing frameworks that promote knowledge sharing and technology transfer, especially in advanced manufacturing processes. Key insights and comparative analysis. While China has made remarkable advancements in sectors such as electric vehicle EV production and nuclear technology, its innovation capabilities in robotics and AI have historically lagged behind those of the U.S. However, recent trends indicate rapid progress, particularly in industrial robotics, where China leads in the installation of robots and has significantly increased its domestic capabilities. The emphasis on integrating advanced technologies from foreign firms into local production processes underscores this trend. Challenges and differences in innovation approaches. Despite the collaborative potential, significant differences exist in the innovation strategies of the U.S. and China. The U.S. model is predominantly market-driven, fostering innovation through competition and entrepreneurship. In contrast, China's approach is state-directed, concentrating on achieving national strategic goals. These fundamental differences present challenges for cooperation, especially concerning intellectual property rights and technology transfer issues. Timeline of events. 2024 – Initiation of the $3 billion investment rollout plan for AI-driven robotics in manufacturing. 2025 to 2033 – Projections indicate substantial growth in the AI market with a compound annual growth rate of 33.83%. Ongoing, continuous advancements in robotics and AI across both nations, with China focusing on the rapid deployment of AI technologies across various sectors including manufacturing, healthcare, and transportation. Conclusion. The anticipated deployment of AI-driven robotics in manufacturing represents a pivotal step for both the U.S. and China in enhancing their industrial capabilities. While challenges persist due to differing economic models and innovation practices, the collaboration is set to drive significant advancements capable of reshaping the manufacturing landscape in both nations. The success of this initiative will depend not only on the financial investment but also on the ability to navigate the complexities of international cooperation in technology and innovation. As the global manufacturing environment evolves, the integration of AI-driven robotics will be crucial for maintaining competitiveness and ensuring sustainable economic growth. Counterintuitive insights on the deployment of AI-driven robotics in manufacturing, U.S.-China collaboration. 1. Investment doesn't guarantee innovation success. While the U.S. and China are set to invest $3 billion in AI-driven robotics for manufacturing, the assumption that this funding alone will lead to significant technological advancements may be misleading. Historical trends indicate that large investments do not always yield proportional increases in innovation or productivity, particularly if the underlying systems and structures to foster creativity and efficiency are not in place. 2. China's perceived lag in innovation. Many analysts argue that China is still behind the U.S. in key areas like robotics and AI. However, the rapid advancements in these sectors suggest that the narrative of China as a mere copier may be outdated. The evidence points to China's capability to leapfrog in certain technologies, potentially surprising skeptics who underestimate its pace of innovation. 3. The dichotomy of innovation models. The contrasting approaches to innovation between the U.S. and China may lead to unexpected outcomes. The U.S. model emphasizes market-driven innovation while the Chinese model is state-directed. This could mean that despite the U.S. leading in foundational technologies, China's more aggressive industrial policy might allow it to dominate in applied technologies, leading to a shift in global technological leadership. For quality versus quantity in R&D, the common belief that the U.S. excels in the quality of research compared to China overlooks the sheer scale of China's efforts in producing a large number of scientific publications and patents. The perception that these outputs lack quality may not hold, as the increasing number of impactful Chinese patents indicates a growing capacity for high-quality innovation. 5. Misinterpretation of innovation. The definition of innovation often centers around groundbreaking inventions. However, incremental improvements can also represent significant competitive advantages, especially in industries with high fixed costs and low marginal returns. Both nations need to recognize that sustained economic competitiveness often relies on continuous, albeit smaller, innovations rather than solely on disruptive breakthroughs. 6. Collaborative efforts lead to complications. While the U.S.-China collaboration in AI-driven robotics is framed as a beneficial partnership, historical rivalries in differing economic models may complicate this relationship. The expectation that both countries can work together seamlessly in high-tech sectors may underestimate the potential for mistrust and competitive tensions to disrupt collaborative efforts. 7. The role of policy and regulation. The idea that free market principles alone can drive innovation fails to account for the importance of supportive policies. In China, state intervention plays a crucial role in fostering innovation through subsidies and strategic direction, which contrasts starkly with the more laissez-faire approach in the U.S. This difference could result in China gaining a competitive edge in industries where government support is essential for rapid scale-up. 8. The impact of demographics. The assumption that China's aging population will slow its economic growth may be countered by the potential for a growing middle class that could drive demand for higher quality goods and services. This demographic shift may provide opportunities for advancement in technology sectors, contradicting the notion that demographic challenges will hinder China's innovation capabilities. 9. Intellectual property concerns. The apprehension surrounding intellectual property theft in the context of U.S.-China collaboration may overlook the nuanced ways in which knowledge transfer can occur. Instead of outright theft, the blending of ideas and innovations could lead to a more integrated technological landscape, which may ultimately benefit both countries in unforeseen ways. 10. Global market dynamics. The belief that China's rise as a manufacturing powerhouse must come at the expense of U.S. firms does not account for the possibility of a more collaborative global economy. As nations become increasingly interdependent, the potential for mutual benefits through shared advancements in technology could reshape competitive dynamics in ways that challenge traditional zero-sum thinking. These counterintuitive insights underscore the complexity of the U.S.-China collaboration in the deployment of AI-driven robotics in manufacturing, challenging simplistic narratives and encouraging a deeper understanding of the evolving technological landscape. The report on the deployment of AI-driven robotics in manufacturing through a $3 billion investment between the U.S. and China for the 2024 rollout is filled with intricate insights, many of which may be overlooked. Here are the significant points that warrant deeper attention. 1. Investment allocation and phased rollout. The $3 billion investment is not just a financial figure, it represents a strategic alliance between two of the world's largest economies. The phased approach suggests a careful, methodical deployment of technology which may allow for iterative learning and adaptation. This is significant because it reflects a long-term vision rather than a short-term financial commitment, showcasing the importance of sustained collaboration and technological advancement. 2. Rapid growth projections in AI. The prediction that the AI sector will expand from $184.15 billion to $2.53 trillion within a decade indicates a fundamental shift in manufacturing paradigms. Many might overlook how this growth is not merely a financial opportunity, it represents a transformative change in how industries will operate. The emphasis on AI-driven robotics signifies a potential leap in efficiency, productivity, and supply chain management, altering competitive dynamics on a global scale. 3. Use cases broadening beyond traditional manufacturing. The applications of AI-driven robotics extend beyond mere automation of manual tasks. The report mentions predictive maintenance, supply chain optimization, and quality control, which are crucial for minimizing operational costs and improving product quality. This broader application suggests a paradigm shift towards intelligent manufacturing systems capable of self-optimization, which could redefine industry standards and practices. 4. Differences in innovation approaches. The contrasting innovation strategies between the U.S. market-driven model and China's state-directed approach may not be immediately apparent. The report highlights that while the U.S. relies on market forces to drive innovation, China's model often involves significant state support and strategic direction. This difference is crucial for understanding potential frictions in collaboration and the implications for technology transfer and intellectual property rights. 5. Intellectual property concerns. The report hints at the challenges posed by differing approaches to intellectual property IP and technology transfer between the two nations. This is significant because it could hinder the collaboration both in terms of trust and potential legal disputes. Understanding these nuances is critical for companies looking to engage in joint ventures or shared projects, as they must navigate a complex landscape of regulations and expectations. 6. China's rapid technological advancements. The report mentions that despite China's historical reliance on foreign technology, it is rapidly advancing in sectors like AI and robotics. This insight is often overshadowed by the narrative that China is merely a copycat. However, recognizing that China is developing its indigenous capabilities and potentially surpassing U.S. firms in certain areas is critical, as it alters the competitive landscape and strategies employed by U.S. companies. 7. Potential for market disruption. The emergence of a new generation of AI-driven robotics could disrupt existing market leaders. This potential for disruption is significant, as it suggests that companies currently at the top of their industries may need to adapt or face obsolescence. This could lead to a more dynamic market environment where agility and innovation become paramount for survival. 8. Collaboration models and frameworks. The emphasis on joint research and development initiatives with frameworks for knowledge sharing might be overlooked as mere bureaucratic processes. However, these frameworks are fundamental for fostering innovation ecosystems where both countries can benefit from shared insights and technologies. This aspect of collaboration could be the backbone for future advancements and a model for other international partnerships. 9. Societal and economic implications. The broader economic implications of deploying AI-driven robotics are significant. The potential for job displacement, changes in workforce requirements, and shifts in economic power dynamics are often sidelined in discussions focused solely on technology. Addressing these societal implications is crucial for policymakers to ensure a smooth transition and to mitigate potential backlash against automation. 10. Long-term strategic competition. Beyond immediate economic benefits, this collaboration signals a long-term strategic competition where technological supremacy is a key focus. This aspect is essential for understanding not only the economic motivations behind the investment but also the geopolitical implications. The interplay between technology, economic power, and national security is central to the ongoing U.S.-China rivalry. In conclusion, the significance of these overlooked aspects lies in their ability to inform stakeholders about the complexities of international technological collaborations. As both countries move forward with their AI-driven robotics initiatives, understanding these intricacies will be crucial for navigating future challenges and opportunities in the global manufacturing landscape. 1. Investment and rollout phases. The collaboration between the U.S. and China is marked by a significant $3 billion investment aimed at deploying AI-driven robotics in manufacturing. This rollout will occur in phases focusing on various applications such as supply chain optimization and predictive maintenance. The anticipated growth of the AI sector projected to expand from $184.15 billion in 2024 to $2.53 trillion by 2033. Highlights the urgency and strategic importance of this collaboration for both nations. Understanding how these investments are structured and the specific phases of deployment will be crucial for assessing the effectiveness and impact of this initiative. 2. Integration and collaborative efforts. The partnership is not just about financial investment, it also involves joint research and development initiatives that leverage the strengths of both countries. The focus on creating frameworks for knowledge sharing and technology transfer is essential for fostering innovation in advanced manufacturing processes. This collaborative approach can enhance the competitive advantage of both nations in the global market, particularly in sectors like robotics and AI. Analyzing the mechanisms of this collaboration will provide insights into how both countries plan to navigate their differing economic models and innovation practices. 3. Differences and challenges. The contrasting innovation strategies between the U.S. and China present both opportunities and challenges for collaboration. The U.S. model emphasizes market-driven innovation while China follows a state-directed approach. This fundamental difference raises concerns regarding issues like intellectual property and technology transfer, which could hinder effective cooperation. A detailed examination of these differences and the potential obstacles they create will be critical in understanding the dynamics of U.S.-China collaboration in AI-driven robotics in manufacturing. For key insights on innovation capabilities, the report highlights the rapid advancements in Chinese innovation capabilities, particularly in robotics and AI, which are critical for the manufacturing sector. While the U.S. still leads in certain areas, China's fast-paced growth in sectors such as electric vehicles and nuclear technology indicates that its companies are becoming formidable competitors. An in-depth analysis of the current state of innovation in both countries will shed light on the competitive landscape of advanced manufacturing and the potential implications for global industry standards and practices. These 4 points provide a foundation for a deeper analysis and discussion on the deployment of AI-driven robotics in manufacturing, focusing on investment strategies, collaborative efforts, challenges posed by differing economic models, and the implications of innovation capabilities in the U.S. and China. 1. The U.S.-Japan semiconductor trade war of the 1980s. In the 1980s, the United States faced a significant economic challenge from Japan's rapidly advancing semiconductor industry. The U.S. government and key companies like Intel and Texas Instruments feared that Japan's aggressive pricing and state-supported firms would dominate global semiconductor markets. In response, the U.S. initiated a series of trade measures and agreements, including the Semiconductor Trade Agreement in 1986, which aimed to ensure fair competition and protect American interests. This historical case underscores the complexities of international industrial competition and the role of government intervention in protecting national technological leadership. 2. The Airbus vs. Boeing rivalry. The competition between Airbus and Boeing illustrates the intense global race for dominance in the aerospace industry. Airbus, founded in 1970 as a consortium of European aerospace companies, was backed by substantial government support and subsidies from member countries. Boeing, a long-standing leader in the aviation market, faced challenges as Airbus gained market share with its innovative A320 and A380 aircraft. This case highlights the tension between state-sponsored industrial policies and market-driven competition, revealing how government involvement can significantly influence the trajectory of technological advancement and market dynamics in high-stakes industries. 3. China's rise in electric vehicles (EVs). In recent years, China's aggressive push to dominate the global electric vehicle market serves as an illustrative case of state-directed industrial strategy. The Chinese government has invested heavily in EV production, providing substantial subsidies to domestic manufacturers like BYD and NIO while simultaneously restricting foreign competitors' market access. This strategy has allowed China to capture a significant share of the global EV market, making it the largest producer and consumer of electric vehicles. This case exemplifies how strategic government investment and policy can rapidly transform an industry and shift global competitive dynamics. The deployment of AI-driven robotics in manufacturing is poised for transformative growth starting in 2024, supported by a substantial $3 billion investment aimed at enhancing collaboration between the U.S. and China. This joint initiative is a strategic response to the increasing global competition in advanced manufacturing and reflects both nations' ambitions to lead in technology and innovation. Investment and rollout phases. The investment will be allocated across several phases targeting different aspects of AI and robotics integration in manufacturing. This includes funding for research and development, R&D, workforce training, and infrastructure improvements. The U.S. and China recognize the need to significantly enhance automation and efficiency to maintain competitiveness in an ever-evolving global market. The global AI market is projected to experience exponential growth, rising from $184.15 billion in 2024 to approximately $2.53 trillion by 2033, with a compound annual growth rate (CAGR) of 33.83%. This underscores the urgency for both countries to capitalize on advancements in AI technology. Use cases and applications. AI-driven robotics will be deployed across various manufacturing applications such as 1. Supply chain optimization. AI systems will facilitate real-time data analysis to improve inventory management and reduce delays. 2. Predictive maintenance. Advanced AI algorithms will enable manufacturers to predict equipment failures before they occur, minimizing downtime and maintenance costs. 3. Quality control. AI-powered visual inspection systems will enhance product quality by identifying defects early in the production process. These applications will not only streamline operations but also reduce costs and improve overall productivity. Integration and collaborative efforts. The collaboration between the U.S. and China will emphasize joint R&D initiatives, pooling resources and expertise from leading companies and academic institutions. This partnership aims to establish frameworks for knowledge sharing and technology transfer, particularly in advanced manufacturing and robotics applications. The integration of AI in manufacturing processes is expected to lead to significant advancements in efficiency and productivity. Key insights from various sources. Analyses indicate that while China has made notable progress in sectors like electric vehicle production and nuclear technology, its innovation capabilities in robotics and AI still lag behind the U.S. However, China's rapid advancements in these areas, particularly in industrial robot installations, showcase its commitment to improving its manufacturing capabilities. Chinese firms are increasingly adopting advanced technologies, often through partnerships with foreign companies, which accelerates their learning and innovation processes. Differences and challenges. Despite the potential for collaboration, significant differences exist in how the U.S. and China approach innovation. The U.S. system prioritizes market-driven innovation, while China's model is more state-directed, aimed at achieving national strategic goals. This divergence creates challenges in cooperation, especially concerning intellectual property rights and technology transfer. Both nations must navigate these complexities to foster a productive partnership. Timeline of events. 2024 – Launch of the $3 billion investment plan for AI-driven robotics deployment in manufacturing. 2025 to 2033 – Anticipated growth in the AI market, with a focus on expanding capabilities in manufacturing, healthcare, and transportation through AI integration. Ongoing, continuous advancements in AI and robotics technologies in both countries, with an emphasis on improving production processes and efficiency. Future outlook. 1. Increased automation. Manufacturing sectors in both the U.S. and China will likely see a surge in the adoption of AI-driven robotics, leading to enhanced automation and reduced labor costs. This shift will necessitate workforce retraining and upskilling efforts to prepare workers for new roles. 2. Global competitive landscape. The collaboration may shift the balance of power in global manufacturing. If successful, both nations could dominate the AI-driven robotics market, potentially impacting countries that do not keep pace with these advancements. 3. Technological innovations. As AI and robotics technology continue to evolve, new applications and solutions will emerge, further revolutionizing manufacturing processes. This could lead to breakthroughs in areas such as smart factories, where interconnected systems optimize production in real time. For policy and regulation, the governments of both countries will need to establish regulations and policies that support innovation while addressing challenges related to data privacy, cybersecurity, and ethical considerations in AI deployment. 5. Potential for disruption. While the collaboration is promising, it may also provoke concerns regarding competition and dominance in key technologies. The U.S. and China may find themselves in a race to lead in AI and robotics, potentially leading to geopolitical tensions if not managed carefully. In conclusion, the deployment of AI-driven robotics in manufacturing, backed by a substantial investment in collaboration between the U.S. and China, represents a pivotal moment for the future of industrial capabilities in both nations. While challenges remain, particularly in reconciling differing approaches to innovation, the potential for significant advancements in efficiency, productivity, and competitiveness is immense. The trajectory of this initiative will shape the landscape of global manufacturing for years to come.